I'm Jenny Weand, and I'm from Potomac Highlands Regional Jail. Today I'm going to talk to you about plotting categorical and quantitative data. The types of graphs that we are going to discuss are the bar graph, line graph, the pie chart, the dot plot, stem and leaf, box plots, and scatter plots. Let's talk about the difference between categorical and quantitative data. We're going to start with categorical. Okay, these are items that are grouped together based on common qualities, attributes, characteristics, and properties. Okay, it's also referred to as qualitative data. So some different types of categorical data would include the days of the week, your eye color, the type of pet you own, months of the year, your favorite toppings on pizza. Those are all qualitative or categorical types of data. There's also three types of categorical data. It's your nominal, ordinal, and interval data. In nominal data, the order does not matter. So when you're posting that data, things like jersey numbers or student ID numbers, they can be listed in any order and it really wouldn't matter. With ordinal data, the order does matter, but the intervals in between the data is not necessarily equal. For example, movie ratings on a scale of 1 to 5 stars or an earthquake Richter scale. With the interval data, your order does matter, and there is a difference in the values, which is important. Things like temperature. The temperature between 70 and 80 degrees is the same interval as if it was between 50 and 60 degrees. So the three types of graphs that we're going to talk about with categorical data is the bar graph, the pie graph, and the line graph. Starting with the bar graph, this is the most common form of a graph that we typically see. It's great for comparing multiple items based on the height of the bars. So in this example, we're comparing fruits and the number of fruits that exist. So you can see that blueberries scored the highest versus grape, which had the least number. You may also find that the bar graph could be flipped and the bars could run horizontally as well. The second type of graph is your line graph, and this is best for showing change among one or more variables over time. It also helps to show if there are any patterns or trends that are occurring. So in this example, we're looking at the temperature. In blue, it's the high. In blue, it's the low, and in red, it's the high. And we're looking across the days of the week. So it would appear that the temperature went down as the week went on until it reached Thursday, where then the temperature went back up. You'll also see line graphs commonly used with businesses. They like to compare their profits over the months, over years, quarterly, and those types of things. So the line graph is really good, again, for looking at trends and changes over time. The third graph is called the pie graph, and it shows parts of a whole. And it's most commonly used when your data is given to you in percentages. So if a survey was provided and they asked you what your favorite types of pizza toppings are, based on this graph, we could see that 50% of the people responded that pepperoni was their favorite topping. Okay, 25% of the people surveyed had said that cheese was their favorite topping, and then it was the supreme pizza followed by sausage. It's very important with pie graphs that your percentages all add up to 100%. If they don't equal this amount, it could make your graph very misleading. So now let's get into some of the quantitative data. These are numerical variables that represent a measurable quantity. So when we talk about height, heart rate, bank accounts and balances, the number of tickets sold at stadiums across the country. Those are all quantitative values. We can measure and count those numbers. We're going to talk about the dot plot, the histogram, the stem and leaf plot, a box and whisker plot, and finally the scatter plot. You're going to find that a lot of these graphs and charts have very similar attributes to them, and there's just a little bit of differences among them. Starting with the dot plot, it's very similar to a bar and line graph. If you look, the dots kind of look like bars on a bar graph, okay? Also, you could connect them kind of like you would on a line graph, okay? The nice thing here is that because it's a quantitative chart, we can find the mean, median, mode of the data set. So what this represents is fuel economy, miles per gallon, and here we would see that this is 15 overall miles per gallon. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9 people said that their fuel economy was 15 miles per gallon. Versus over here, only 2 people said that they were getting 40 miles per gallon. So again, if we were to add up 14 plus 14 plus 14 plus 14 plus 15, etc., and we did that for all of our data and then divided it, we could find the mean. Similarly, if we were trying to find the median, we could use a cross-cancellation method and go through our data. Eventually, you would see that you would get into the middle, and somewhere around here you would find your median score. The mode is very simple to find because you just have to find the highest bar. So we can see that 23 had the most answers, so that would be our mode. Typically, the dot plot is most appropriate when you're talking about small numbers and categories. Even in this example, it's almost too much data to look at, so you want to make sure that if you're going to have a larger data set, that you would look at a different graphing option. For example, the histogram. It differs from the dot plot in that it's actually used for large amounts of data. What you'll see is the difference between a histogram and a bar graph is that there's no spaces in between your data sets. And what they end up doing is they take their data and they group them into smaller intervals, which we call bins. So when we talk about the height of black cherry trees, okay, we have intervals of 5. So this is 60 to 65 feet, 65 to 70 feet, 70 to 75, and so on. Okay, and as we read through this graph, what we can see is that, let's just take this one for example, there were 8 trees that were approximately 70 to 75 feet tall. Okay, there was approximately 5 trees between 80 and 85 feet tall. Again, this is great if you have large amounts of data, but the only problem with the histogram is that you can't get the exact values. So even though we know that there were 3 trees between 60 and 65 feet, we don't know exactly whether it was 61 feet or 63 feet tall. That's the part that we're missing. The stem and leaf plot, again, can take on the shape of a bar graph, histogram, or a dot plot. Especially if you were to take this and turn it, you would see that you basically would have something that would resemble bars. When you're making a stem and leaf plot, what you're going to do is basically this number right here represents 10, 13, 16, 21, 26, 27, 28. So it's just another way of graphing your data. You can also determine your measures of central tendency. So if we were to add 10 plus 13 plus 16, etc., divide it out, you would get your mean. Similar to the cross cancellation, This would give us, okay, and if we continue to do that, we would then find our median. And once again, we can determine the mode, we just have to find repeating numbers. So here, 35 repeats 2 times, and we can also see that 41 repeats itself 2 times. So therefore, your mode would be 35 and 41. Okay, once again, similar to the dot plot, the stem and leaf is best used with small sets of data. Now, the next one is called a box and whisker plot. And it definitely takes on a different shape than some of the previous graphs that we've talked about. The big key to the box and whisker is that it organizes your data into percentile ranks. Okay? Also, you can determine your distribution and if there's any outliers in your data set. So, there's 5 measures that we look at closely and that we need to know in order to create the box and whisker. We need to know the minimum and maximum values, and then we need to determine what's the first quartile, the median or second quartile, and then our third quartile. So to do this, we're looking at 1 mile run times. 5:48 was the quickest time. That would be our minimum. 12:09 was the maximum. That was the slowest time in the 1 mile race. Here, 7:50 represents the median time of the racers. And to determine your first and third quartiles, what you will do is add all your data between your minimum and your median, and then you'll find the mean of that data. And then for the third quartile, you will add all your values between the median and the maximum number, divide it, find the mean, and that gives you your third quartile. The final graph that we're going to look at is called a scatter plot, and this is used for bivariate data. So basically you need to have 2 values and you're determining if there is a correlation between those 2 values. So in this example, we're looking at beach visitors. And we have the number of visitors that go to the beach, and we also have the average daily temperature. So when we take a look at this, we can kind of see that as temperature increases, so does the number of visitors to the beach. Okay? And so we can conclude, or we can try to draw a correlation and say that as temperature increases, so does the amount of people that go to the beach. Further research may then study to see if one causes the other. And also, when you're doing a scatter plot, you look at something called the line of best fit. And what that is you're basically creating a line that runs through your data and is as close to your data points as possible. And that just kind of creates your linear line and just helps it to see the graph a little bit better. If you look down here, we can also see some different types. If our dots are closer together, we have basically a perfect positive correlation. So if we can draw a line right over all these data points, that's a good thing. Okay? Here you can see it's a little bit more scattered, but we still can tell that we're moving in a positive direction. Okay? Again, now you see that the dots are way more spread out, so we're starting to lose some of that positive correlation. When you get over here, there's really no direction. I wouldn't know where to put my line, so there's no correlation that exists. And then again, the same occurs for a negative correlation. Okay, we go to a perfect negative correlation. And then again, you can see the difference in the dots. So let's just do an example here to compare some of our different graphs using quantitative data. We're going to look at the WVU football schedule and results for 2014. What we're really focusing in on is the number of points scored at each game in the 2014 season. If we were to draw this as a histogram, okay, you can see that we created 5-point intervals, and we can see that 4 games they scored between 35 and 40 points. Of course, without looking specifically at our data values, we don't know, again, was it 37 points? Was it 40 points? We're not quite sure. We just know the range. But if we look at this, we can see that the majority of their games were scored in under 40 points. Okay? So again, that lets you look at the distribution of data. Now, if we were to take that same set of data, we can create our stem and leaf plot. So what we're going to do is we're going to put the front number on the left side. That's our stem. So we have 1, 2, 3s, and then we have 4, and there was one game where they scored over 50 points. To fill in the leaf, we're just going to place the right number. Okay, so we have 16, 20, and 23. We have 30, 33 2 times, 34, 37, and then we go down to 40, 41, and 54. So here we've now filled in our stem and leaf plot. You can see that the 37 would be our mode of data, and also we could find the median if we do a little cancellation here. So I'm just crossing out until I get to my middle number. And our median is then going to be 34. Okay, and our mode would be 37. And we can also find the mean if we were to add up all of our numbers and divide them out. Okay? The next thing we're going to do is a box and whisker plot. So looking at the data, I've already highlighted 3 of our measures. We have the minimum, the median, and the maximum. So we can go ahead and plot those on our graph here down below. So 16 is going to be our minimum, and 34 is our median, and 54 is the max. Okay. Now what we need to do is the first quartile and the third quartile. So we added up all of our values between 16 and 33. We add those up and we divide by 6 and we get 27.5. So we can now add that also onto our graph. We do the same thing for the third quartile. We add from 37 over to 54 and then we divide by 6 and we get a score of 41. So we can now plot that point. So now what we're going to do is draw the box. Okay. And then we just connect our minimum and our maximum points. Just to make that look a little cleaner. And what we basically can see from this is this right here would be your first quartile. This is your second quartile, your third quartile, and then from here to here is your fourth quartile. The last thing I want to talk about before before we finish up is watching out for misleading graphs. So the bar graph is very, very easy to make deceptive. In this example, we're comparing the Times newspaper to the Daily Telegraph. And the Times, if you first look at this at a glance, you would think that the Times newspaper outsells the Daily Telegraph by double. But actually, the values show a much closer result. They sell about 485,720 newspapers versus the Daily Telegraph, which is still 446,954. So really the values are a lot closer than what this graph makes it appear to look. And part of that is because of our y-axis here. In our vertical axis, the number that they start with is 420 and they end with 490. So the values don't start at 0 and they're very close together with their intervals. So it really skews the way the data shapes on that graph. The same thing occurs down here if you look at this bar graph. They talk about the percentage who agreed with a court decision. And it makes the Democrats look extremely favorable here at 62%. You would think that the Republicans and independents were actually against the court's decision. But if you really take a look at the data, you'll see that 54% of Republicans agreed with the court, as did the independents. Again, that's compared to the 62% of the Democrats. So these numbers and the shape of the bar graph is very misleading if you were to just take a quick glance at that information. Also, you don't typically use a bar graph to show percentage data. So that also can be a little bit misleading with this graph. Over here, the opposite thing happens. We usually would use percentages for arena funding or for pie graphs, and what you see is they actually put numerical values in there. And this is talking about arena funding, and they're saying that 265 million were paid from the city. And then you have the rest of your data. Well, this would indicate that 50% of the funding comes from here. But if you add these values up, that's nowhere near 50%. So again, the pie graph is very misleading, and it's not a percentage, so it doesn't add up to 100%. So it's really not a good display of information. That's going to be the end of our session here today. If you have any more questions, please feel free to visit our web help desk or give us a call, and we'd be more than happy to help you. Thank you.